In this video, I will show you how I converted a dash cubby, found on many Ford vans, into a GPS display unit. The cubby is found on the upper dash and to the right of the steering wheel. It is about the most useless compartment feature on the vehicle. Since it's made of smooth plastic, anything you place in the cubby tends to slide out under acceleration or when on uneven terrain. The coin slots cannot really hold coins as a single bump will send them flying about the cab. The intention is to replace the cubby with a commercial off-the-shelf, GPS display unit. The cubby insert provides enough space for the LCD screen, 2 momentary on switches, and a photoresistor. These components will be mounted to a 3D printed bezel including factory matching mounts to fit the dash opening. The rear will provide mounts for the LCD, the power supply board, and the GPS antenna. The teardown begins by removing the 6 screws on the bottom of the unit. There's number 1. And 2. Three. Four. Five. And 6. The bottom simply falls away. This exposes the power supply board that includes a small speaker and the photoresistor that adjusts the brightness of the LCD screen. This board is the LCD driver mounted on the rear of the LCD screen. There are a few other features of this board that will be shown once the board is out of the case. The final board is the GPS antenna and battery. The battery allows the memory to be maintained for a while for faster startup when the vehicle is started again after shutdown. Remove the 2 screws retaining the power supply board. Pop the front bezel off to expose the LCD board and screen. Now slide the LCD unit out of the case. The LCD driver board contains a few more components. There is an Arduino controller on the board as well as a quartz clock at 5 MHz. These, in conjunction with some memory EEPROMs holding the programming code, constitutes the controller that serves up the display on the LCD from the decoded GPS signal. Now time to measure the cubby dimensions, particularly the factory tabs and clip positions, and sizes, so the new bezel will snap into place on the vehicle dashboard. The LCD board and display all need to be measured to ensure they will fit properly within the new bezel, as well as providing location positions for securing the boards to the bezel. When doing this kind of thing to produce a system that fits properly, it's never a one and done. All these components were measured over and over again as new ideas and configurations popped into my head until I had a final design. Now save the drawing out as an STL file for 3D printing. Now that you can hear again, I am using a 120 grit paper on a sanding block to do final cleanup on the edges and surfaces. Be careful not to sand too aggressively. You cannot put material back on. This sanding just evens out the curves and makes everything consistent prior to priming and painting. I am using denatured ethyl alcohol to remove all the sanding residue as well as greases and oils that may affect the paint. Ethyl alcohol is probably the best degreaser for plastics. Don't use any stronger solvents like acetone as it will melt the plastic. Filler primer works best on 3D printed plastics since it will fill in the lines created by the additive process. Each coat is a wet coat. I am spraying close enough to lay down a thicker layer and it looks wet. If the nozzle is farther away, the primer looks drier as it's applied. I allowed the solvents to flash off before applying the second coat. It was a cold day, so I kept the primer and paint in the house to keep warm, but the outside temperature extended the flash time to about 30 minutes. Normally, you see it flash in about 10 minutes. After allowing the solvents to flash again, I applied the last coat of filler primer. I am using Rust-Oleum 2X coverage flat black paint. This can be applied right over the flashed primer. Unless there are defects that need to be corrected prior to painting, there is no need to sand the primer before painting. If you let the primer completely dry, you should do a light sanding before applying paint. Paint coat number 2. Final coat of flat black paint. The clear coat is Rust-Oleum 2X coverage matte clear. You should always clear coat your painted items. This creates a tougher layer than the paint, and if any scratches happen you can polish the clear coat to remove them. I allowed the clear to flash off, then applied the second and last clear coat to the bezel. Looking good. Just waiting for the clear coat to flash off and flatten out. I let it sit for a couple weeks so the clear coat would cure completely. Set the GPS antenna mount to the support mount using acrylic glue. This melts the two pieces together, forming a single unit. Test which solder joints respond to the existing switch clicks, as the new momentary switches will be installed in parallel. Cut and strip the switch leads. Tin the switch leads with plenty of solder. Solder each lead to the circuit-mounted switches. The new momentary switches are just paralleled off the existing switches. Cut the photoresistor off the power supply board. Cut and tin two extension leads, then solder the extensions to the board. Time to get the LCD and board mounted and secured. I printed a couple of risers that grab the edge of the board and hold it tight to the bezel. Using the nut supplied, insert and tighten the two momentary switches firmly. Strip and tin the switch wires. I ran each switch wire pair, attached in parallel, to each switch and soldered them. Connect the GPS antenna wiring to the LCD board. Now I pull the wires for the photoresistor through the mounting hole and solder the photoresistor to the wires. Using RTV silicone, I secure the photoresistor to the mount. Now I am attaching the cabling between the power supply board and the LCD board. Again, using RTV silicone, I am securing the GPS antenna to the plastic antenna mount. A little bit more RTV, and the power supply board is secured. Power up the unit and test functionality. First thing to do is remove the dashboard. Now to find accessory power. There is a connector directly behind the cubby slot on the dash. This connector I think is used for vehicles that have other gauges in that slot, or 12-volt power sockets, as an option at purchase. The black wire is the ground, and I found ACC power on the white wire right next to it. I tested with a multimeter and it works. The best part is it is fused on the fuse panel. Sever the white and black wires. Terminate each wire with a connector. Now this can be tucked back behind the dashboard. Plug in the power to the unit and start the vehicle. The power should turn on and the unit start up. Now we are waiting for the GPS unit to acquire at least 4 satellite signals. The dashboard is back on the vehicle and the power cord for the GPS is ready to be connected. The dashboard is back on the vehicle and the power cord for the GPS is ready to be connected. Size it up one more time. I plugged in the power and snapped the bezel into the dashboard. The bottom centering clips were a little tight, but tapping on the top seated them and I was able to roll the top locking tabs into place. The tabs are so exact I don't think I could get it out in one piece. Testing the power switch. It must be held down until the unit powers off. Same situation for powering up manually. With everything working well, the time has arrived for the most satisfying part of the build, removing the protective plastic from the LCD screen.